All right, so we completed that first opening exercise together. Next, we're going to work on this exploratory challenge. So notice that the big question on the board today is, can a graph prove proportionality? So we're going to test to see if there's a special relationship in the graph if we have a proportional relationship. So it says, using the ratio provided, create a table that shows money is proportional to the number of candy bars sold. Plot the points in your table on the grid. So if I sold 2 candy bars, I get $3. I'm going to continue with this ratio. So let's say I sold 4 candy bars. How much money would I get? I would get $6, right? So I'm doubling that. Let's say I sold 6 candy bars. How much money would I get? Well, if I increase my candy bars by 2, my money increases by 3. If I increase this by 2 more, my money is going to increase by 3 again, since it's a proportion. And my last one, what if I had 8 candy bars? How much money would I get? Continue the pattern, that's 12. Now, is this really proportional? Well, if we test it out, 3 divided by 2 is 1.5, so that's $1.50 a candy bar. 6 divided by 4 is also 1.5, $1.50 a candy bar. 9 divided by 6 is also 1.5, $1.50 a candy bar. And 12 divided by 8, look at that, also 1.5. So we know this is a proportional relationship, okay? Let's graph it. Now, I hope we remember how to graph. First, do you remember what this axis is? That's the x-axis. What about this axis? That's the y-axis. How do we graph a table on a coordinate plane? Well, when I see that there's x is candy bars sold and y is money received, I'm going to label that. This is candy bars, and this is money. Okay. So if I see that I have 2 candy bars sold and I got $3, I'm going to see that 2 candy bars, $3 point, and I plot that. 4 candy bars for $6. 6 candy bars for $9. And then there's 8 candy bars for $12. Go ahead and plot that, and you can pause and catch up with me. So next, what do you notice about this graph? There's something special about it. What do you notice? Well, one thing I notice is that it's a straight line, or it looks like a straight line, but how do we make sure? We take our ruler. Do all the dots, all the points perfectly match up? They do, okay? So what we do when they all match up is we connect all of our points, and we go in both directions all the way like that, okay? It is a perfectly straight line. What else do you notice? Well, I notice one more thing. This line passes through this special point. Do you remember what that 0, 0 point is called? That's called the origin. That's called the origin. Special things about proportional graphs, they're always going to be straight lines, and they're always going to pass through the origin.